All right, we're going to talk about, starting chapter 3, some applications of derivatives. One of those applications is finding extrema. Another name for extrema are basically mins and maxes that happen on the graph. So there are open intervals, which means don't include the endpoints, and there are closed intervals denoted by brackets, and this means do include the endpoints. Both of these A and B would represent X values. You would actually have to plug A and B and any points in between into the graph to find out what their Y values were. I've given you an idea of what a picture of this may look like here. F prime of X is equal to 0 will show a place where there is a horizontal tangent. Okay, we'll say down here that F prime of X equals 0 is something that's known as a critical number. This is an X value, which is a critical number. Okay, so here in the derivative, if I plug this X value in the derivative, it gives me derivative equal to 0. There's some sort of turning point probably happening here. I say probably. X is equal to 0. If I choose this X value right here and I plug it into the derivative, what it also shows me is there's a horizontal tangent here. The derivative equals 0, which means there's a horizontal tangent there. So on this particular closed interval, there were 2 critical points. One here, one here. Now, if it's a closed interval, you have to check all 4 things in this case. You check the Y value at the endpoints, and you also check the Y value at any critical points. So if we do that, we see that the highest Y value actually belonged to this first critical point here, so we call this an absolute max, and the lowest Y value actually belonged to this endpoint here, so we call this Y value here an absolute min. The other 2 are somewhat forms of extrema, but we can name them relative max and relative min. They are smaller than the points generally right next to them, okay? But they are not the highest and the lowest parts of the graph. Those are known as absolute min and max, okay? Guidelines for finding extrema. First of all, we set the derivative equal to 0. This finds critical numbers. Again, remember, critical numbers happen when the derivative equals 0. This means horizontal tangents exist. Usually, and I'm going to say the word usually, this means they're turning points of some sort. That means mins and maxes, whether they're absolute or relative, as in this case, are generally happening. If you then check those values along with the values of the endpoints, then you will find out that the highest value you find is a maximum and the lowest value is a minimum. Let's look at open intervals for a minute. Open interval, again, these are X values, A and B. So in this particular case, this graph is decreasing the whole way down, and there's an open circle on A and an open circle on B. No absolute min or max exist, because if you name me a value right here, I don't know, 2.9, I can name 2.99, and that's a Y value I'm talking about. Okay, any value you can name me inside this interval, I can probably name you 1 point higher because of the nature of having an open circle. Over here, even though the graph is an open interval, it also contains a place where the derivative equals 0. It contains a critical number. Therefore, we check all 3. Can't find anything here or here because no Y value exists. A limit exists, but it's not an absolute Y value. Here, however, a Y value does exist, and it is the lowest point on the graph, so an absolute min exists, but no absolute max exists. Looking at about 3 examples. First of all, just checking this one. It says find the absolute max and min on the interval. Let's just talk common sense for a minute. This guy here, especially if we look at it separated like we rewrote it here, it's linear function. It's an upward sloping linear function. The absolute min is going to be on the left. The absolute max is going to be on the right. All right. However, let's make sure we know this with calculus. So first of all, we set the derivative, which is just a constant, and we set it equal to 0. All right. When will 2/3 be equal to 0? Never. There are no critical points because of horizontal tangents. It just doesn't happen. All right. So then we just check the Y value of the endpoints. We plug in 0, and the Y value is 5/3. We plug in 5, and again, this is to the original equation, and we see that the Y value is 5. So therefore, 5 is the apps max, and 5/3 is the minimum Y value. Looking at another function of some sort, this cubic function evaluated on the closed interval 0 to 4. So first of all, we take the derivative. We take the derivative and set it equal to 0. This finds critical numbers, which are also places where horizontal tangents happen. So we do that. 3x squared minus 12 that we found using the power rule. 3x squared equals 12. Divide by 3. X is plus or minus 2. These are critical numbers. So we check the Y values of the endpoints, 0 and 4, and of 2, This is a critical number that's happening because the derivative equals 0, but we don't check -2 because -2 is not on our original interval. So 0, f of 0 is 0, f of 2 is -16, f of 4 is +16. So if we'll check out the smallest y value, the one that we found because it was a critical number and it was a turning point, that's our absolute min. Our highest y value actually was from the endpoint of 4, and that's our absolute max. What if we look at it, part of it intervals closed, part of it intervals open? So first of all, I wanted to check the derivative. So I rewrote. I used chain rule and power rule to find the derivative. All right. I clarified a little bit. A half times -2 is just -1. I set it equal to 0. Well, how do you set a function equal to 0? You actually set its numerator equal to 0. So if I do that, I find out that that only happens when x is equal to 0, which is already an endpoint. So there is no critical number that happens in here because the critical number that causes this to be equal to 0 is already an endpoint, and actually it's open, so that's a problem. So the only thing I really have to check here is I have to check -2. So when I plug in -2, 4 minus -2 squared is 4 minus 4, so that y value is 0. If I check what's happening towards 0, just like we used to check limits, as I approach 0, I actually am approaching a y value of 2. But since it's an open circle, that absolute max does not exist. So the only thing that guy has is an absolute min, and it happens at the x value of -2 with a y value of 0. Good enough for today.